Hi everyone, welcome to another project showcase video. And today I'll be showing you a project that I've been working on for the past couple of weeks. It is called Forge. So Forge is a AI coding agent. You can think of it as something similar to Claude Code, but the idea wasn't to clone Claude Code. It was to understand how modern coding agents work internally, like tool calling, MCP integration, sub agents, memory, and everything. So yeah, I've basically tried to do that. So let me show you around the project. It is a terminal based project similar to Cloud Code, and this is the main screen. Um, it shows you the model you're using, the current working directory, and the commands. Let's go over the commands. Uh, so you have help, exit, clear, config, model. Let's look at the model. So currently we're using this model from Inclusion AI. You can basically use any model you want from Open Router. So it supports like 450 models, and you can just type this command slash model and the model name that you want to use, and you can use that model. You just have to set the API key and base URL for that. Then let's go over to the tools that are supported by our coding agent Forge. So these are the tools. It supports 29 tools, out of which these are the inbuilt tools. These are the sub agents. We'll go over what sub agents are. And this test tool, it is basically we basically allow the users to create their own tools with very minimal config. So test tool is that. Sub agent test is also a sub agent that is created by the user itself with very minimal config, like a few lines of code, not much. And file system tools. These file system tools come from an MCP. Yes, you also support an MCP. Let me also show you that. So yeah, currently we have the file system MCP connected and it shows 14 tools. These are those 14 tools. Yeah, then we also have a very dynamic config system. Let me show config. You can basically set the model, temperature, approval mode, working directory, and max turns, and you can change everything. It is basically a simple TOML file. Again, let's look at this approval. What is this approval? So, our model can basically perform a lot of stuff like rewriting a file or performing a shell command, as we have those tools right here. But some of those operations can be quite dangerous. So, we want user's permission and only then will perform those operations. And this is the approval system that we have created. So basically you set the approval policy that you want to use. By default, I am using the on request policy. On request policy means if the model thinks, okay, this task is quite dangerous, we need to ask the user. So it will ask the user permission. If the user allows, only then the task is performed, else the task is not performed. Let's look at another policies. If I set something like YOLO, then LLM will never ask the user. It will perform any task it wants to perform by itself. So let's change it back to on request. And then we have we have a lot of stuff, but let's not waste our time in this. Let's jump to an example. So let me run this again. And let's just ask a very basic, simple thinking. Hi, how are you? I asked this basic thing, and the core of Forge is an agentic loop. So if you give an agent task, it will iterate until the task is completed. It will call the LLM 5 times, 10 times, 20 times, call as many tools as it wants to, but it will complete the task and only then it will stop. It can also stop before that if the max turns are over. But yeah, let's see. I asked the LLM, "Hi, how are you?" This is what the LLM thought. So all of the reasoning is also shown to the user. You can, if you don't want to see this, you can turn it off from the config. And I'm doing well. Thanks for asking. How can I help you today, Pranjal? Now, how does it know my name? That is from the memory. We have a memory system, and the agent can store and get stuff from memory, which and this memory works across sessions. So let's ask the agent what it remembers about us. So what do you know about me? What do you know about me? And yeah, so the agent used the memory tool to get the username. The agent used the user interest to find another thing. And from my memory, I know my name is Pranjal and my I like cheesecake. That's all I know about you. Is there anything you'd like to remember? So here's the memory that the agent can use as well. Another thing is we have is sessions. So let's save this. So this session is saved. We can reload this session whenever we want. So let's copy this and let's call sessions. So these are the sessions that I've saved. Um, this particular session that we just saved, it had 3 turns and it was updated this. Then we also have checkpoints, which we can use in between of sessions. But enough of this, let's perform an actual task. So let's ask it to do something complex that will require a lot of tool calls. So let's ask us to create a Netflix clone using HTML, CSS, JS. Create it in Netflix directly. So we've asked it to create a Netflix clone and let's see what it does. So it thought about it. It used it to do tool to add it into the memory. So basically it planned on what to do. Obviously, it didn't work, it threw an error, but the agent didn't stop. The LLM solved the error and pivoted to another task. Then it called the shell tool. Shell. It is throwing some errors because I think the LLM doesn't know how to use PowerShell or something. But yeah, it managed to use dir. Good, the Netflix directory says I need to create the Netflix loans files. It will create the HTML, CSS, and JavaScript files. This is how this is basically all of its thinking process, reasoning abilities, and it obviously depends on the LLM that you're using. So it called the tool write file. It created a file of 116 lines. You can see the diff 116 file diffs. Then it created the CSS file, which is okay, 844 lines of CSS, and it is still thinking. It is not over. I have given it just one simple prompt, and it is still iterating, and it will continue to do so the until it has completed the user's request. So yeah, it also wrote the JavaScript file, which is of 553. Another thing we have over here is context management. So since it is reading all of this and writing all a lot of content, over time its context window will get full. For that, we have context pruning and context compaction. We see that okay, the context is about to be over, so we trim the context, we prune the context to manage long running, which is very important. And a lot of agents like Codex does it very well. So it created the tool, it created the Netflix clone. It also created Netflix clone is created with three files, index, app, style, and these are the features included. Let's look at the output and also figure out. Um, yeah, this was the user-made tools and sub-agents I was talking about. And here's the Netflix directory and open the index. Okay, it has done a very well job actually, considering it only had HTML, CSS, and JavaScript. And also, I'm not using a very good model as well. If you use something like Claude, you would get much better results as well. So this is something. And yeah, this is all I wanted to show.